All right, welcome back to another homework video. This is our 1.3 lesson. We are going to go over all these answers. Please again make sure that we are using this video for your resource. This is a thing I offer you so you can check your answers. You can also see how to do problems if you didn't know how to do them. What I care about more is that you understand how to do the problems rather than try and write something down really quick just so I can see something on your paper. So let's get into this. I'm just going to add for number 3, -4 plus -1. Well, I've got 4 negatives and I've got another negative, and I'm just adding them all together, meaning I get a total of 5 negatives. All right. Again, this is where the visual model is really nice. Helps us when we are, when we are looking at this. Also, if you wanted to do it on a number line, remember we go to -4 and we just hop backwards 1. That would also show us an answer of -5. Okay. For number 8, this one is just really easy. It's just subtraction. I take 451, I take 268, and make sure everything is lined up, and we are ready to go. I'm going to notice that I can't subtract 1 from 8. I'm going to take away from my neighbor. I'm going to borrow 1. I now have 11 minus 8, which is 3. I then can look, and I can't take 4 away from 6, so I'm going to borrow from my neighbor again. 14 minus 6 is 8. 3 minus 2 is 1. My answer is 183. Again, just like a simple subtraction. For number 9, it is asking, what is the range of the numbers below? In 6th grade, hopefully you had learned that the range of a number set is, well, how big is a set of numbers? Or how big is a data set? All right, you're going to notice I'm doing a voiceover. I recorded all of this video without my voice, so now I'm watching my video and voicing over. All right, what does that mean? How big is the data set? All we have to do, big number minus small number, and that's going to give us our range. So when I look at my set of data on the left, I've got 4 multiple choice answers. It's going to be really easy once we start looking at all this, because, well, all I have to do is look for the biggest number and the smallest number and subtract them. So there's our data set. I'm going to look for my biggest number. That would be 30. My smallest number, right, is the only one that is a single digit, is 8. Last step, take my big number minus my small number. 30 minus 8. Again, if you need to do this quick, borrow from the neighbor. 10 minus 8 is 2. 2 minus 0 is 2. I get an answer of D, 22. That is the range of my data set. For 13, I've got my first question here. These are all adding, so we never have to do any chopping. Remember in class we talked about how when we add fractions, we need to make sure that we have no mixed numbers, meaning I need to do my around the world. 5 times 1 is 5, plus 1 gets me 6. There it is. 6 over 5. Remember, my denominator stays the same. There's a negative out front, so my fraction is negative. I'm going to add in the rest of it. I see that it's plus -3/5. I have common denominators, so I'm all good there. I don't have to worry about changing anything. And now, remember in class, we just have to really look at the top numbers. Okay? If I look at my numerators, I have -6 plus -3. If you need to make a quick little visual model, go for it. 1, 2, 3, 4, 5, 6. 1, 2, 3. I have 6 negatives. I'm adding 3 more negatives, meaning I have 9 negatives. Don't forget to add in your denominator at the end. I have an answer of -9/5. This works out great. If you want to be more specific, you would also could have an answer of -1 and 4/5. That's the mixed number version. Picking up with number 16, we now have two decimals being added together. I have 12.48. I have negative 10.636. Right? 12.48 is positive. 10.3636 is negative. When I have this case, when we have two opposite signs, it's easiest to think that when I have two opposite signs, I'm going to subtract them, right? I have starting with a lot of positive, and I'm adding negative, so I'm adding a bunch of these zero pairs in there. So I'm taking away from positive. To set this up, we take our bigger value, 12.48, put it on top, subtract it by 10.636. Don't forget about your placeholder 0. And from here, it's just subtracting. I can't do 0 minus 6, so I need to borrow from my neighbor. Again, I'm doing a voiceover because my other video didn't record sound, and now I'm watching my video and talking about it. So borrow from my neighbor. There's 7. I have 10 now. 10 minus 6 is 4. 7 minus 3 is 4. I can't do 4 minus 6, so I need to borrow from my neighbor again. This becomes a 1, and then 14. 14 minus 6 is 8. 1 minus 0 is 1, and then the 1s cancel each other out. So my answer is 1.484, or 4, oh my gosh, 1.844, there we go. To make sure it's either positive or negative, I look at my bigger value. My bigger value was positive, meaning my answer stays positive. Okay. Moving on to number 17, I've got two fractions. One of them happens to be a mixed number here. When I start this, I like to make sure my mixed fraction is put into an improper right away. 6 times 2 is 12, plus 1 is 13. My denominator remains the same. There's a negative out front, so make sure that you have a negative there as well. I'm adding negative 2/3 to it. My next step in my thing is to see, do I have common denominators? I do not. Thankfully, this example is very easy to get common denominators. I just multiply the bottom by 2. Whatever I do to the bottom, I also have to do to the top. Because of that, I am going to rewrite my equation really quick. Negative 13 over 6 doesn't change. This now becomes plus negative 4 over 6, right? Negative 2 times 2 gets me negative 4. All right. Again, in class we talked about, hey, just look at the top numbers and add those really quick. Negative 13 plus negative 4. I have 13 negatives. I add 4 more of them. I should get to negative 17 over 6. Right? That is an acceptable answer. If you wanted to, you could also write it as a mixed number. 17 divided goes into 6 2 times. Left over is 5, so my answer would be negative 2 and 5/6. Moving on to number 18, I've got negative 20.25 plus 15.711. Okay? What we said about decimals is, hey, let's look at our signs. I have a negative, I have a positive, right? I'm starting negative and I'm adding positives, or I'm getting more positive or less negative. So, because I have two different signs, I need to subtract my numbers. I'm going to start with the bigger value. The bigger value out of these is 20.25. That is going to be the first number on top. Because they're different, I should be subtracting them. On the bottom goes 15.711. Perfect. Again, different signs mean I am subtracting them. Right? Two different signs, positive, negative. With those, I should be subtracting. I'm going to fill in my extra placeholder 0 so I don't forget it. And let's start subtracting. I got to borrow from my neighbor right away. 10 minus 1 is 9. 4 minus 1 is 3. Can't do that, but I have to borrow again. And I can't do 0, so I got to go all the way over to 2. This becomes 10, but now I need to borrow, so I'm going to actually make it 9. Then I can make that 12. 12 minus 7 is 5. There it is. Add my decimal point. 9 minus 5 is 4. And my 1 minus 1 is 0. So, I get a value of 4.539. I look back. What was my bigger value to begin with? It was a negative value to begin with. So my answer should be negative. Last of the first 5 of the kind of example problems. I have 15 over 4 plus a negative 4 1/3. Let's do the around the world right away, just to make sure we've got it. 3 times 4 is 12, plus 1 is 13. This is going to be negative. Remember, there's a negative out front in there, right? But make sure we keep our denominators the same as what they were originally. This was 3. Okay. So, from here, I can't easily make common denominators, right? I don't have anything that I can multiply by 3 to get to 4. So instead, I'm going to do our second strategy, which was just multiply it by the other denominator. So 4 I would multiply by 3, and 3 I would multiply by 4. Remember, whatever you do to the bottom, you got to do to the top. I'm going to redraw my fractions. My common denominator now is going to be 12. For the first one, 15 times 3, let's think about a clock. 3 15-minute increments. I have 15. Half hour would be 30. 3/4 of an hour gets me to 45. All right. Again, drop down your plus. It's still going to be negative, right? From here, I like to think about a deck of cards. That's how I remember 13 times 4. There's 13 different cards in a deck of cards, and there are 4 different suits. Because of that, 13 times 4 is 52. 52 cards in a deck. That's how I always remember 13 times 4. All right, let's start looking at our numerators again. That's how we saw it is easy to add these two numbers. I have a positive 45. I have a negative 52, meaning I have 2 opposite signs, right? There's my positive, there's my negative. Because of that, I'm going to take my bigger value, 52, and I'm going to subtract away 45. Doing this quick, I got to borrow from my neighbor really quick. Again, I circled there just because to show I need to subtract. They're different. Take away from my neighbor. 12 minus 5 is 7. 4 minus 4 is 0. I should get an answer of 7 on top, 12 on the bottom. My denominator remains the same. 52 had a negative attached to it, so that means my answer has to be negative 7 over 12. Okay. Number 25. Your bank account balance is negative $20.85. Oh no, what happened? You deposit $15.50. What is your new balance? Let's talk about this word deposit. It means put into the bank. And I think I'm going to write back here. Whoops. I mean bank. Right, I'm putting money in. I am adding. So this is an addition problem. If I want to write this out, I've got negative $20.85 plus, because I am depositing, $15.50. All right, this is just like we've done before. I'm going to look at my signs. My bigger value is $20.85. My smaller one is $15.50. $20.85 is negative. $15.50 is positive. 2 different signs mean I need to subtract. 5 minus 0, that's going to equal 5. 8 minus 5, that's 3. Drop my decimal point. Got to borrow from my neighbor really quick. 10 minus 5 is 5, and then 1 minus 1 is 0. I can kind of just ignore that 0 for now. I know my answer is $5.35. I just need to look and see that my first initial bigger value was negative, meaning my answer is negative. Properly, it would be negative $5.35. All right, there's a quick recap of the first one. On the back side, right, we're going to go through a bunch of these word problems. Number 27. Let's see how good of a job I do with the voiceover. So, if we read this problem, it's saying you are adding two rational numbers with different signs. All right. Now, rational numbers, again, if you need to remember, they are any number that can be written as a fraction. For this example, I kind of want to use a number line because I think it's going to be a really nice visual to help us with this two rational numbers with different signs, the whole thing. Two different signs just means one's positive, one is negative. On my number line, I'm going to make a 0. And let's put, kind of fill in that to the left would be negative, to the right would be positive. Those are what we've got. So, in this, I've got one in the red, one in the yellow. And it's asking us, how can we tell if the sum is going to be positive, negative, or 0? Let's start with 0. Right? Let's say I have negative 1 and positive 1. Those are both rational numbers. Well, we know that negative 1 and 1 are 0 pairs. And a 0 pair is any two numbers that when added together get me 0. So if I am looking for two numbers that have different signs that I want an answer of 0, I just need 0 pairs. All right, I think I'm going to write what that means. Yep, a number and its opposite. I have 1, its opposite is negative 1. If I add them together, I get 0. Nice and easy. Now, what about positive and negative? I'm going to start with positive. All right. If I am looking at two rational numbers, one of them's positive, one of them's negative, and I'm going to add them together, well, what we need to do is, I've talked about it before, is we need to kind of look at the values of these two numbers. Whoop, too big of an eraser there. If I kind of get rid of 1 and I go a little bit more to the right, let's say to 1.5, that's a rational number. Notice how when I look at the values or the distance from 0, that 1.5 is clearly bigger than negative 1. That means I've got more positives than negatives. I've got more positive space than negative space. So if I have two rational numbers and their signs are different, I know my answer is going to be positive. I'm going to wait for myself to start writing because I know what I said, but I just want to confirm. There it is. I know it's going to be positive if the value of the positive number, right? We learned about absolute value. If the value of the positive number is bigger than the negative number. There we go. 1.5 is bigger than negative 1. If I looked at their absolute values, I would have 1.5 and 1. 1.5 is clearly bigger. That was my positive one. I know my answer is going to be positive. All right. Same thing goes for negative, but it's just kind of reversed, right? So eventually when I get there, I'm going to kind of erase negative 1 and 1.5. And I'm going to go back to 1. 1's nice and easy to work with. But now I'm going to say, hey, what about negative 1.5? Again, still a rational number. We're still good. Notice that space with the negative is now bigger. and the value of it is bigger. So when I have two rational numbers with different signs, all I have to do is if the value of the negative number is bigger than the positive. There we go. Yeah. So again, it's going to be negative if I see two numbers. If the value of the negative number is bigger than the positive number, I can already know my answer should be negative. Right? We talked about this a lot on the last page. If we look at number 18, we said that negative 20.25 is bigger than positive 15.711 as far as their value goes. Because of that, I knew my answer had to be negative. That's exactly what we were talking about. As well as number 25. Again, 20.85, that's a bigger value than 15.58. Because it was negative, my answer ended up being negative. So again, that's kind of the wording for 27. But we've already done a bunch of examples where we already seen how this plays out. All right. Using properties of commutative and associative properties of addition, can you help find the sum using mental math? Again, big words here, but what this is saying is instead of following the parentheses right away, can you move the parentheses so that it makes this problem a whole lot easier? When we are just adding or just subtracting, I can move my parentheses all I want. And so what I actually want to do is I'm going to make parentheses around 2/3 and 1/3, and I'm going to start right there. Okay? 1/3 plus 2/3, right? We know what this is. Keep the bottom number the same. 1 plus 2 on top is 3. What is 3/3 simplified? Well, 3 divided by 3 is just 1. Now, if I substitute in that 1 for 1/3 plus 2/3, I just showed it equaled 1. I now have a really easy equation to solve. 1 plus 5/8. I'm just going to smash them together to get my answer of 1 and 5/8. So, by moving around where my parentheses were, I made it so much easier than adding 2/3 plus 5/8 right away. 1/3 plus 2/3 was 1. All I have to do now is tack on the 5/8. For number 31, it's saying, hey, same thing here. I have all these bunch of different numbers, 4 and 1/10 and negative 8 and 1/2. Whoa, that's going to be a lot of work if I try and do that right away. Okay? Instead of looking at those two, I'm going to kind of zoom out and see, hey, I've got a positive 8 and 1/2, and I've got a negative 8 and 1/2. Guess what those are? Those are zero pairs, right? And we already know that when I have a number and its opposite added together, that it's gonna equal 0. And with zero pairs, I can just cross them out. They cancel each other out. So this whole big addition problem now is just this number 4 and 1/10. And that's our answer. Right? Zero pairs sometimes it makes our life so much easier because we don't have to worry about all that extra work. We can just cancel them out and look at, we're left with that one term. I just need to write that down. Again, this is more of an 8th grade and high school thing. Commutative and associative properties, you will learn all about them. You will know them like the back of your hand. You will be able to use them. It will be great. For now, we're just kind of showing the basics of how they work, and we just want you to know that. All right, 3 to go. We got this. For 33 and 34, I've got a bunch of different things going on. I've got decimals, I've got fractions, and I've got whole numbers. Oh my. I'm going to show you how we can actually work with these pretty easy. Unfortunately, we have to do some changing. Now, in number 33, I'm going to change all of these to decimals because I only have one fraction. So, negative 4.3, that's already a decimal. I don't have to change it. When it comes to 4/5, I can make this a decimal pretty easy by just dividing 4 by 5. Right? Numerator goes in the garage, denominator goes outside the garage. I'm going to think, how many times does 5 go into 4? Well, it doesn't. So I'm going to write a 0. From here, I need to remember, draw my decimal and add a 0. Don't forget the decimal point above. Now I think, 5 can go into 40 8 times. 8 times 5 is 40. I get a remainder of 0. And would you look at that? I just changed 4/5 into 8/10. Those are the exact same. So, when I substitute it in, I have negative 4/3 plus 8/10. 12, well, that's kind of already a decimal. It just doesn't have anything. You could say 12.0 if you really want. Okay, this is going to be really easy if I combine my positive values. All right, I'm going to do this first. 12 plus 0.8 is just 12.8, right? Now I'm only dealing with two numbers, and this is where, yet again, I have a negative value, I have a positive value. If I have two different signs, I know that I need to subtract. I'm going to start with the bigger value in 12.8, and just like before, we're going to subtract our two numbers because my signs are different. 12.8 minus 4.3. Let's do this quick. 8 minus 3 is 5. Add your decimal. I need to borrow from my neighbor. 12 minus 4 is 8. My answer for that is going to be 8.5. I'm going to look back at my value. Right, 8.5. I need to look back at my value. My value was positive with 12.8. That was my bigger one. So my answer stays positive. All right, for this one, I've got two fractions going on. So I'm actually probably better off changing everything to fractions, right? It's going to be a lot easier. Before I do that, I'm also going to make all of these mixed numbers into improper fractions. 3 times 5 is 15 plus 1 is 16. All right. 16 over 3 is my first one. For 7.5, 0.5 as a fraction is just 1/2. So, to make a mixed number, it would just be 7.5. From here, around the world, I could do 7 times 2 is 14, plus 1 is 15. Keep my same denominator, though. Remember, it's not 3. Well, it was 2 up above. Same thing goes for our last value. 6 times 3 is 18, plus 1 is 19. There's a negative out front. Remember, that negative needs to stay. All right, I've got my 3 fractions that are improper. I'm good. I don't have any mixed numbers. But now I need to get my common denominators. What's nice about this is that both 3 and 2 can go to 6. I just need to multiply 3 by 2 and then 2 by 3. Whatever I do on the bottom, I need to do on top. And because of that, this is going to allow me to get all of the same common denominators, and that common denominator is going to end up being 6. All right. So, again, common denominator is going to be 6. 16 times 2, if you need to do that quick, you can. 32 is the answer you should get. Again, 6 on the bottom. 15 times 3, we just did this. 3/4 hours. That'll be 45 minutes. Finally, my last one stays the same because it already had a denominator of 6. Remember that negative 19 needs to stay as well. Okay, let's start with the positive values. 45 plus 32. I'm going to zoom in a little bit here. 45 plus 32. I'm just going to look at the numerators. I know my denominator is going to be 6 already, so I can put that there. 2 plus 5 is 7. 3 plus 4 is 7. I get in my numerator 77. I'm going to fill in what I had left then, which was plus negative 19 over 6. I have a positive. I have a negative. We've done this whole rodeo a whole bunch. Opposite signs mean subtract. 77 minus 19. Borrow from my neighbor. 17 minus 9 is 8. 6 minus 1 is 58. I get an answer of 58 over 6. Remember, 77 over 6 was positive, so my answer stays positive. My mixed fraction, I need to know how many times does 6 go into 58? It goes in 9 times. How many are left over? Well, that would be 4/6. All right. If you really want the simplified versions, you could take, 4/6, that's just 2/3. If you had 58 over 6, that's a great answer. 9 and 4/6 is better. 9 and 2/3 is the best. Okay, last problem. Here we go. The table at the right shows the annual profits in thousands of dollars at a county fair between 2013 and 2016. What must the 2017 profit be to break even over the 5-year period? Okay. I want to start talking about this word even. In the financial realm of things, breaking even means that your profits and your expenses is just 0, right? We are looking to see out of all of our profits that we made over there, how would we make it to 0? Easiest way to do this, we're going to add our positives, we're going to add our negative numbers together, and then we are going to do some subtracting. 2.5 plus 1.4, right? I should have 5 plus 4 is 9. Add your decimal point. 2 plus 1 is 3. That is my positive profits. My negative profits, I'm just going to add them together really quick. 3 plus 4 is 7. That's not where the decimal point goes. 4 plus 1 is 4, or 3 plus 1 is 4. Remember, these were negative, so my answer is negative. I've got a positive. I've got a negative. So I'm going to subtract them. Take my bigger value of 4.7 minus 3.9. I'm going to borrow from my neighbor. And that's going to be 3. 17 minus 9 is 8. 3 minus 3 is 0. Okay. My 4.7 was negative and it was bigger, so my answer is negative. So I've got this negative 0.8. That is how much after the 2013 to 2016, that's where I'm at. I've actually lost money. Okay? When it's asking, what do I need to break even over the 5-year period? Essentially what I'm going to think to myself is, in 2017, I need to add something so that when I add it, I'm going to equal 0, right? That would be me breaking even. Well, we have two numbers that when added together equals 0. That sounds familiar. That's just a 0 pair. So a 0 pair is a number and its opposite. The opposite of negative 0.8 is positive 0.8. Right? I would gain $0.8 thousand. Meaning in 2017, that question mark, I would need to make 0.8 thousands of dollars to break even. All right. So that is our homework explanation for everything. Oh, I forgot about this part. If some of you saw that we had 0 pairs already, you could just cross them out right away. That made less adding and subtracting for you. That was my other point. Great job if you saw that. I kind of forgot about it. All right, there's our homework. Right, great job on this. Thank you for doing your best. Use this as a resource, not just a way to copy answers down. If you still have questions, please let me request you for topper time, and we can continue to go through this. So, We'll catch you in the next homework video.